Okay, this is the third time I'm recording this video because the freaking PowerPoint keep on crashing. So I'm praying that it'll work. Wait, if you see this, then it works. But yeah, so we're talking about composite functions here for section 5.1, and we start with a little exploration, right? And so here we have a tanker that is leaking oil, and it's forming a circular path around the tanker. And the radius r is increasing the rate of 3 feet per minute. So part A, they're asking you to model this radius r as a function of time. So basically, what do you do with time to get the radius? Well, it's increasing 3 feet per minute. Okay, so radius as a function of time. So that's r of t equals to 3t, right? Because it's increasing 3 feet per minute. And then part B, model the area of the oil spill as a function of r. So they want the area as a function of r. What do you do with r, radius, to get the area? So that is just basically area of a circle. So area as a function of r is pi r squared, right? And take r, take radius squared, and then times pi. And then the last part, now they want you to model the area as a function of time. It's basically putting the two functions together. First, you have radius as a function of time, and then area as a function of radius. And now you put them together, you have area as a function of time, right? So basically, you just replace r with 3t, basically. So now you have area as a function of the radius as a function of time, basically give you the area as a function of time, which is pi times 3t squared. I replaced r with 3t because that's what r is. That's a function for r. So that is what composition of functions is. Okay, you're putting functions together. So here's a definition of composite functions. Okay, so we write f with the little dot and then g of x. So we write this as a f composed with g. So all it is it's just f of g of x. Okay, and let's see what that means. We're going to do some evaluating. Okay, so here they give you f of x and g of x. And part A, they want you to find f composed with g of 1. So using the definition, it gives you f of g of 1. Right, so when you evaluate this, you want to do the inside function first, which is the g of 1. So I do g of 1, which is 4 times 1, which is 4. That's based on g of x. And then since g of 1 is 4, I take that and I plug it back in for my f. So now I have f of 4. And then I put 4 in for the x of f. And I evaluate, which is 2 times 4 squared minus 3, which ultimately gives me 29. Okay, so recap. I do the inside function first, which is g of 1. And I evaluate g of 1. Once I get that value, I plug it back in for the outside function, which is f. So f of 4, which gives you 29. Part B, g composed with f. So writing this out with the definition, it gives me g of f of 1. And then so I do the inside, I'm going to evaluate f of 1, okay? You do f of 1, what do you get? So f of 1 gives me negative 1. And then I take that and I put in for the outside function, so g of negative 1. And I plug that in, and I get 4 times negative 1, which is negative 4. Part C, f composed with f at negative 2. So with the definition, I have f of negative 2. So I do the inside, which is f of negative 2, which gives me 5. And then I put it in for the outside function, which is also f. So f of 5 gives me 2 times 5 squared minus 3, which gives you 47. And then part D, g composed with g at negative 1, which by definition is g of negative 1. So I do the inside, g of negative 1 is negative 4. And then I put that into the outside function, which is also g, so g of negative 4, which is negative 16. Okay, we can also evaluate this from the graphs, right? So here is the graph of f and g. F is the red one, g is the blue one. And then part A, they want f of g of 2. So do the inside, I want to do g of 2, so the blue one at 2. So I will look for x is 2, the input is 2 right there, and I look to the function to see where it's at, right? So when the input is 2, my output is 5, right? Because that's the point on the graph. So the output is 5. That's the inside. G of 2 is 5. Now I take that and I put it into the outside function, which is f. Now I do f of 5. And I go to 5, and I look to the function of f, and that gives me that value right there, which is 4. Input is 5, output is 4, so I get 4. Okay, let's try that again for part B. G composed with f at 4. So by definition, this is G of f of 4. Now I do f of 4. I go to 4 and I look to f, and f gives me the value of 2. And I take that 2 and I go to the outside function, which is g. And I go to g and it goes up there, which gives me 5. So same idea for C and D. You guys try that and then we can check the answer with each other. And the last part of this is to find the domain of composite functions. So the first step is to find the domain of the inside function. And the second step is to find the domain of the outside function using the inside function as x. So that is a little bit confusing, but we'll see what that means as we go through this, okay? And basically the domain of the composite function is the intersection of the two domains of these two steps that we're doing, okay? So in reality, all you have to do is to find the, what do you call that? The exclusion of the domain of these two things. Okay, so number one, so here's an example. They give you f of x and g of x. All right, so step one, I want to find the domain of the inside function. By the way, they want you to do f composed with g of x. So that is f of g of x. So the inside function is g, the outside function is f. So you do the domain of the inside function. So you look at g of x, I have x minus 1 at the bottom. So x minus 1 cannot be equal to 0, right? So the domain x minus 1 cannot be equal to 0. And you solve for x. That's easy. X is equal to 1. And then step number 2, find the domain of the outside function using the inside function as x. Okay? That means that you look to the outside function, and the bottom is x plus 2. And typically you would have x plus 2 not equal to 0, but now you have to plug in g of x into that x. So instead of x plus 2 not equal to 0, I have 4 over x minus 1 plus 2 not equal to 0. So basically, what I did was I replaced that x right there with the function g of x, which is 4 over x minus 1. Okay? And then I solve for that, I subtract 2 by both sides. 4 over x minus 1 equals not equals to negative 2. Multiply x minus 1 on both sides. Now 4 equals to negative 2 times x minus 1. Distribute that. Solve for it. And I get x not equal to 1. And so that's my domain. I have x not equal to 1, x not equal to negative 1. Part B, the domain of f composed with f. So that is f inside, f outside. Again, do the domain of the inside. So x plus 2 not equal to 0, so x cannot be equal to negative 2. And then you do the domain of the outside, which is also f, but now you replace x with f. All right, so x plus 2 not equal to 0, now you have 1 over x plus 2 not equal to 0. And solve for that, solve for it, solve some more, solve, x not equal to negative 5 halves. And so my domain is x not equal to 2, x not equal to negative 5 halves. And that's it for 5.1. We can go ahead and do 5.2.